Hi, I'm Mark Wilson, the Engineering Heretic. Today I want to look at chamfers and chamfering tools, and here I have a particular chamfering tool that I use quite often in my drill press. It's a 3-footed tool, and it will do down to around about 3 or 4 millimeters. I have a larger one of the same configuration. But this particular tool is good. But what I want is a smaller one for doing tiny holes and things like that. Things related to clocks and things like that. Tiny screws and things like that. And I want to make a little chamfering tool to countersink small holes. So what I'm going to do is go on my D-bit grinder and I'm going to make a particular tool. Now it's a spade type chamfering tool. I'm going to use some high-speed steel. I'm going to make two, one for my drill press and one I'm going to put a wooden handle on and just twiddle it by hand. So that's what I'm going to do. It's going to be a spade type one. It's going to be round. It's going to be quarter round, split halfway, and then a cone ground on the front of it, and a slight facet on the front face here. And I'll tell you, and I'll deal with this facet thing down the track. There's a couple of little things you need to know about D-bit grinders in order to be able to do this properly. Now this is going to be, I call it a reaming type cutter where it's supported. Now this edge here, if I was making a cutter, a pure cutter, this edge would be standing proud. There'd be a relief angle down here, and then it would be relieved underneath here. I'm not going to do the relief, the radial relief. I'm only going to do the relief on the angle up here, starting from nothing at that point there up until there. So, but it'll be around about, I think around about 25 degrees. But I'll talk about a couple of issues that you need to know about on D-bit grinders when it comes to grinding things that self-support or they cut independently. If they're held rigidly and they just cut, or they self-support. Now this particular cutter needs to self-support a little bit and actually make contact with the work and bear on the bottom face. Let's go to the D-bit grinder and I'll tell you, and I'll explain a little bit more. So now we're on the grinder itself. I've got it mounted up in a quarter collet. It may not seem important to start off with, but this head must be vertical when you grind this D. It has an adjustment here to swing over here. I'm going to put that on vertical. That's on vertical there. Now because of the way I set this up when I grind it, if I have this on 0, it's for setting an existing D-bit. If I have this set for if I'm going to grind a D, I need to have that at 180 degrees. And that just drops in there. I actually don't change this position at all. I just leave them fixed. So that's one thing, but we don't have to worry about that oddly enough at the moment. What we want to do first is grind a 45 degree cone shape. So we'll set this around for 45 degrees. 45 degrees there. And because we'll have to see where we are with the head, that's not looking too bad. We're going to have this so we can rotate 180 degrees. We'll start the machine up. And what we need to do is grind this, and I'll change the camera angle as well. Right, so we're going to grind basically just a straight cone. So there's my cone shape, right to a sharp point. Now, oddly enough, to split this in half, well, I don't really have to measure this much. All I need to do is just grind this until I meet that point there. So we'll swing this back around to square. We'll put this stop here on 180 degrees. Drop that in, and now we have to split this in half. So we just wind this away here. Making sure I can see here. I might change the camera angle a little bit. We're going a little bit closer. We'll roughen up the wheel a bit. I don't want that to get too hot. I'm going to grind that until I just reach the point. Now I can actually turn this around and see that easily. I can see there's still a cone existing on the front there. We'll put that back to 180. Turn it around a bit, have a look. Still not quite. Fraction more. That looks pretty good. Right, so that's our D shape there. Now what we want to do is put a relief on this. Now I'm going to do something a little bit different. I'm going to explain a couple of things here. First of all, I'm going to put this to horizontal and put that round to that halfway mark thing. If you can see it here on the thing. So that will do a full rotation like that between its stops. Okay. Now I need to put this back to 45 degrees. Okay. I actually don't need to have this rotating the 180 degrees to get the relief, because I don't want to put the relief radial around this. I want this to be just a flat on the front. Now when I'll just show you, I'm going to re-grind this again at just the front edge there. I'll just dress the wheel a bit and make it a lot smoother. And we'll just tidy up that, I'll just put that back to rotation again. Right, so there's my little D cutter. That will actually do a chamfer, but what I want is a little facet on the front here, but I don't want this radial. Now you would have thought that, what I can do is put this horizontal at 270 and rotate that around 15 degrees off the castellations and have that just latch in there, and that will do that. That actually does not work. What that does is cuts an angle. It doesn't actually work. What I want to do is start from nothing on that front edge there, tapering up to back here. If I do it by just rotating the head itself, that does not work. what you have to do is actually put this back to horizontal, and I'll just move back so you can see this a little bit. You actually need to rotate or change the angle of the head itself, because I don't know why some mathematician will be able to tell you exactly why this is the case, why swinging from down here works and not rotating from there. But you have to put the relief angle on by swiveling the head. So what we're going to do is put this to 20 degrees there. And of course now we've moved a long way over, so what we need to do is move this over. So we'll lock this up here, unlock this, get this around the right spot here, lock this up in the right spot, somewhere around about there. Right, now you'll hear this when it cuts. I'll zoom in a little bit closer so you can see really close here. And you'll hear this thing cutting. I may even change the camera angle. So now what we're looking for is now when this touches here, it will actually start grinding right at the very back first and actually go to a cone point there. So let's see how that works out. So we're bringing our tool in, and you'll see it'll just start cutting on the back first. Okay, now I'm not going to rotate this tool because I don't want the clearance to go radial. I just want the facet at the front. So we'll just swing that in a little bit, and we'll see if I can rotate that around just to see if I can see where it's cutting. You can see here it's starting to grind at the very back point here and nothing at the front at the moment, and that's exactly what we want. Let's have a quick little look. Almost done, we're not quite there yet. Fraction more. I think that will just about do it. Yeah, there we have it. And now we have starting from nothing at the very, very tip, going larger on the way down in a proper cone shape. If I rotated just the head itself, you would get that flat going parallel all the way across and not do exactly what we want. So you have to do your relief angles by the bottom scale, not from the head itself. So how do these particular chamfering tools cut? Let's give it a go. So what we'll do is we'll put it in a drill press. We'll start this up. We'll have to extrude a little bit quicker than that. I'll stay slow because I want the cutter to run slow. We'll just go with a slow drill. So we're just going to drill a little, that's a little 2mm drill, and we'll just drill in a certain way. Right. Now let's put our little chamfering tool and see how it goes. And that cuts a very nice chamfer without chattering at all. Okay, so that's how you make a little chamfering tool. And of course I've got one that I can go as deep as I like there, and it doesn't chatter because it's bearing on the very bottom edge all the way around apart from the flat. So that's my little chamfering tool, and of course I have one that I can use by hand, and then also I've got a shorter one I can use in my drill press. And I'm Mark Wilson, and thanks for watching.